Okay. So now, uh, this is the field, retarded field. And now, the retarded field exerts force on the electron. So the force formula we know for F is equal to ma, or the force is equal to, we can know, E into E. So now these are the two formulas. So equating these two things, Ma is equal to E into what is E? What is the field exerted on the electron? It is nothing but V naught plus VR by L. So what is acceleration? D square Z by dt square. So the distance we can call it as it is in the Z direction the electron is traveling. So d square Z by dt square is equal to minus E by E into V naught plus VR by L. So now d square Z by dt square can be written as minus E by M into V naught plus VR by L. So let us name it as equation number 1. Integrating this equation on both sides. Integrating this equation 1. Integrating 1 on both sides. What I am going to get by integrating? Z E Z by dz by dt is equal to minus E by L. V naught plus VR L into integration of what is the time duration. I can name it as T1 minus T into dt. So now dz by dt at time t is equal to T1. So at time t is equal to T1, that means at this time junction, what is my dz by dz? Distance but is nothing but velocity Vt1. So at time t is equal to T1, so we can write it like this: dz by dt is equal to minus E V naught plus VR by ml into T minus T1 plus a constant. By integrating this one, I am writing. So what is at time t is equal to T1? When I substitute t is equal to T1, this becomes what? 0. So what is c is equal to dz by dt? What is dz by dt is equal to Vt1. So what is the expression of c we got? C is equal to V of T1. Now what is the expression of dz by dt? I can write dz by dt is equal to minus E VML V naught plus VR V naught plus VR into, actually in this expression you need to substitute into T minus T1 plus VT plus VT1. Let us name it as equation number 2. Understood this step? Put to amma andarki. Any doubt in this step? So we are doing the integration. This is the basic expression we have. We are doing the integration. By doing the integration, we are going to get dz by dt is equal to minus EML V naught VR integration of T1 to dt dt. What is that integration? If you do, you are going to get t. So by substituting the limits, you are going to get t minus T1 plus the c. What is c? At time t is equal to T1. What is dz by dt? If you substitute t is equal to T1, T1 you can substitute just this term becomes 0. What is c is equal to dz by dt? What is dz by dt at time t is equal to 0? Here the velocity is equal to distance. Actually what is dz by dt is nothing but velocity. What is the velocity at time t is equal to T1? We are getting Vt1. That's what I'm trying to substitute here. Understood up to this? Shall I proceed to the next point or anything? Is it clear?
Yes, ma'am, clear, ma'am.
What about other students? Amma, is it clear? No responses. Are you able to follow or not?
Yes, ma'am.
Now I'll take another page. Wait a minute. We have got equation number 2. So remember this equation. We'll continue this equation number 2. So again, by integrating equation number 2, what we are going to get, see, by integrating equation number 2, what we are going to get. So see, what is the expression we got? dz by dt is equal to minus e v naught plus vr by ml t minus t1 plus v of t1. This is equation number 2 we got. So integrating equation 2 on both sides. So what is the expression we are going to get by integrating this one on both sides? Integrating this one on both sides, what is the expression we are going to get is uh, z is equal to minus e v naught plus vr ml. So integration of this one can be written as t minus t1 whole square by 2 plus v1 of t1 into t minus t1, because the limits are again t minus t1. Instead of straight away writing this step, in between step also I'll write, otherwise you will not understand. Z is equal to e minus v naught minus vr by ml into integration of t1 to t minus t1 into dt plus v1 of t, uh, integration of v1 of t integration of dt t1, uh, t1 into t. Uh, so if you do the integration, e into v naught plus vr ml t minus t1 square by 2 plus v1 of t minus t1 plus c2. So at time t is equal to t1, my z, what is the distance traveled? Because in the cavity the distance is nothing but what? D. Z is equal to t. So substitute t is equal to t1. This term, this one cancel. What is my z? Z is equal to d. So now what is c2? So c2 is equal to d. Now what is z expression I am going to get? Z is equal to, what is my z is equal to d, so I'll substitute z is equal to d e minus v naught plus vr by ml 2 ml t2 minus t1, substituting at that time. This is one expression, so I'll bring that one first. Z is equal to e minus v naught plus vr ml t minus t1 square by 2 plus v1 of t minus t1 plus d. Let us name it as equation number 3. Now I need at z equal to t2, because I need a round trip time. What is round trip time? At time t is equal to t2, my z is equal to d only. At the time t is equal to t2, z is equal to d only. So d is equal to e v naught plus vr by ml 2 ml. I'll write t2 minus t1 square plus v1 of t into t2 minus t1 plus d. So dd can cancel. What we can write this expression, if you take these terms on the right hand side, what you are going to get, v naught plus vr 2 ml t2 minus t1 square is equal to v1 of t, t2 minus t1. So actually I need T2 minus T1. T2 minus T1 is equal to, when you substitute and simplify, this is the expression you are going to get into V1 of T. So the round trip transit time is nothing but this. So T2 minus T1 is equal to 2 ml E into V naught plus VR into, what is V1 of T? Initially we have taken the expression V naught into 1 plus beta I V1 2 V naught sine omega T1 minus theta G. So the round trip time T naught can be written as, so by making this term maximum, so what is the round trip time T naught dash can be written as 2 ml. I think it is not visible to you. So down trip time T naught dash is equal to 2 ml E into V naught plus VR into small v naught. This is important derivation. What is the round trip transit time? So this is the expression, round trip transit time expression is there. So this can be further written as, in some textbooks if you refer, so the expression is written something differently. Remember this expression, what is the thing we are getting, this complete thing you remember. So this complete thing we remember. So what is it we can write is, the round trip transit time. Further it can be written as, it's taking a lot of time. So the round trip transit time further written as C. So we have the expression T2 minus T1, T2 minus T1 is equal to 2 ml E into V naught plus VR small v naught, 1 plus beta I V1 by 2 V naught sine omega T1 minus theta G by 2. This is the expression we got. So in this is represented as T naught dash. So T2 minus T1 is equal to T naught dash into the remaining expression we can write as it is. So sine omega T1 minus theta G by 2. So now multiplying, let us name it as T2 minus T1 as T. So let us name it as 3, multiplying 3, multiplying with omega on both sides. What you are going to get is omega T is equal to omega T naught dash into 1 plus beta I V1 by 2 V naught sine omega T1 minus theta G by 2. So omega T naught is nothing but, omega T naught dash is nothing but theta dash. So omega T is equal to omega theta dash plus, multiply with omega t naught, you are going to get theta dash beta 1 v1 by 2 v naught sine omega t1 minus theta g by 2. So we have already calculated the bunching parameter. What is bunching parameter? X dash is equal to beta I v1 by theta naught dash by 2 v naught. So omega t is equal to theta naught plus x dash sine omega t1 minus theta g by 2. So this is the time we got. Now omega t is equal to omega t2 minus t1, which is nothing but theta dash plus x dash sine omega t1 minus theta g by 2. So this is the another form of round trip transit time. We can use, actually this is the original form. There we have considered only T naught, round trip transit time. T naught dash we have taken. But by considering the everything, this is the round trip transit time expression we are going to get. Okay, so today what we discussed, just we'll go back and we'll see what are the points we discussed. We have started with the two cavity Klystron efficiency derivation. So efficiency is nothing but PAC by PDC. For that we have calculated PAC, PDC value also we have calculated. From that maximum conversion efficiency is nothing but we got 58.2 percentage, the value we got. That's the maximum conversion efficiency, but practically it is less than 40%. Actually, in some documents we are also observed it is 15 to 25% less than that. It is ideal efficiency because we are taken V2 is equal to V naught and B naught is equal to 1. The coupling quotient is maximum, 100% coupling is happening where those are the conditions we have taken. That is the reason we are getting a maximum efficiency. It is 58.2. Later we have calculated the mutual conductance and voltage gain expressions. Voltage gain also we have calculated. So if you do that derivation, everything, all the formulas are available with you straight away. What is V2, what is I2? Your substitutions is there in these three parameter. Nothing new is there. Just a simple substitutions are there. You can go through it. Okay, next we started reflex Klystron. We know in reflex Klystron there are three voltages are there. One is what are the three voltages we applied in case of reflex Klystron is one is the DC beam voltage, one is the RF input to the cavity, another one is the repeller voltage. So we have to take what is the actually we want first we started our derivation with the round trip transit time. So what is the round trip transit time for the electron to reach to which is moving in the repeller space? Again it is reflected back the repeller and reach to the cavity. That the time taken by the electron to reach to the cavity is nothing but a round trip transit time. So next we have calculated first field intensity. We have calculated due to this field what is the force exerted. We have calculated. Finally we have calculated the distance. Distance we have calculated, that is nothing but Z. So for Z, this is what is the round trip transit time angle we have calculated. So now next part is efficiency of reflex Klystron. So if everything is available, all the formulas are available with us, nothing new in this. So we can complete it tomorrow. Two cavity reflex Klystron efficiency, and we'll start helix 2W TWT. We'll complete both the things by tomorrow, reflex Klystron and helix TWT. Okay, this is about this. If you see this derivation without doing the derivation, if you see this derivation, those derivation looks very tricky and very complex. But when you do the derivation, nothing is there in this derivation. Please try to do the derivations. Don't think that at the end I can do. If you do this one, some of the students have written their papers. I have seen in between there are no steps are there. Finally they got the answer, but how they got